Alright everyone, so today we are studying the topic from the first chapter, that is uncertainty, and the calculations of this topic. And this is by far the most important topic of the first chapter. They ask you a question, they pretty much always ask you a question from this one, especially in paper 2, and that question is of 3 marks, 4 mark question. Alright, so there are different ways. There are basically 3 ways by which they can ask the question, and I'll explain all of it, and we'll be solving examples of all of the variations. So first of all, let us define the uncertainty. So if they ask you for 1 mark just to define or state what is meant by uncertainty, then you write this one: the best estimation of how far the experimental quantity that you're measuring by the experiment is or be from the true value. Right, like how far it can be from the actual value. That estimation is called as uncertainty. We can also define it as the range of possible values within which the true value lies, or within which the true value can lie. We can also define it this way. So here we have an example. A student performs an experiment to calculate the value of g, and given below are the values that he obtained. So I'm going to suppose some of the values. Let's say the first one that he gets by calculation after doing the experiment is 9.7, then he gets 10.1. Alright, so these are just supposed values that the student gets after he performs the experiment to find the value of g. Okay, these are the values that he gets. First of all, what is the calculated value? Okay, now we have a set of values. Which one do we suppose, or which one do we consider as the final value of the experiment? Well, if we have a range of values, we can take the average, and once we take the average, that value can be taken as the obtained value from the experiment. So we have 1 2 3 4 5 6 7. So I'm going to take the average value of g. I can write it as g average equals to the sum of all of them, right? Sum of all the values divided by the number of values. Then you hit it on the calculator, you add all of them divided by 7, you hit it on the calculator, you'll be getting 9.8 meter per second square. That is the acceleration of free fall. Now this is the value that he obtains experimentally. What is the uncertainty in it? Or the value that he gets, how far it can be from the actual value. How do we calculate that? Well, in this case, you can calculate the uncertainty equals range divided by 2. Basically half of the range. And what is range? Range is maximum value minus minimum and then you divide it by 2. So then what was the maximum value that you have in the data? The maximum value was 10.2. And what is the minimum value that you have? Minimum, it is a 9, no sorry, we have this one also, 9.0. So this is the minimum, 10.2 is the maximum. We insert it in the formula, so we'll be getting 10.2 minus 9.0 divided by 2, and then you can hit it on the calculator, you'll be getting 0.6. Now that 0.6 is called the uncertainty in the experimentally measured value of g. And what do we write as? We write it as delta g. Okay, so this is the experimental value that the student performs the experiment, then does the calculation and comes up with the final answer after taking the average. So his final answer was 9.8. And then the uncertainty was 0.6. Okay, so you would be writing it as, first you write the experimental value 9.8, then you write plus minus, and then you write the uncertainty 0.6. So this is how you write the uncertainty in your final answer. Once again, this is your experimental value, or this is the calculated value, and 0.6 is the uncertainty in the measured value. All right, for writing your final answer with the calculated value is also called as principal value. All right, like in the previous case we wrote it as 9.8 plus minus 0.6. So 9.8 was the principal value and 0.6 was the uncertainty. So there are different rules. There are certain rules for the significant figures and for the decimal places that you need to figure out before you write the uncertainty with your final answer or with your principal value. But I'm going to skip this one for a while. First we study more about the uncertainty, and these rules will be studying at the in the very last part of it. Okay, so let me scroll down. Representation of uncertainty. In your exam of A-level physics, they can ask you the question of uncertainty in 3 different ways. Either they can ask you to find the first one, absolute uncertainty, or they can ask you to find the fractional uncertainty, or they can ask you to find the percentage uncertainty. Now this one is the most important one, percentage uncertainty being the most important one, followed by absolute, followed by fractional. And in many of the cases you need to figure out by yourself like which one of these representations of uncertainty would be more compatible. All right, so I'll explain all 3 of them. There are 3 different ways by which uncertainty in the principal value is represented. So here we have a scale of an ammeter. Ammeter is a device which is used to measure the electric current. Okay, so what is the principal value? Let us find the principal value by reading the scale. So principal value, we can write over here, principal value. So the principal value is, if you read the scale, after 5 lines we get 1, then 2, then 3, then 4, followed by 5. So the principal value in that situation would be 1.246. It will be 1.6. So that is 1.6, and we have to write the unit. We always write down the unit, which in this case is milliamperes. We can see it from here. Okay, so this is the this is the principal value. Now what is the precision of this meter, of the ammeter? Precision means what is the smallest reading that it can measure accurately. Well, the smallest reading that it can measure accurately is basically the separation between any 2 small divisions, any 2 small consecutive divisions. Okay, either you can measure from here or from here or from here, from anywhere you measure the separation between 2 consecutive lines, that would give you the precision. So in that case it'll be 0.2, because only then you get 1 after 5 places. So 0.2, 0.4, 0.6, 0.8 and 0.8 and then 0.2 further added, that gives you 1. So the precision or the smallest division is 0.2 milliamperes. Okay, do not forget to write the unit. We always write the unit with everything. So 0.2 milliamperes is the smallest reading that can be taken with this ammeter and the principal value or the reading that you're getting from this ammeter is 1.6 milliamperes. Just keep these two things in your mind, because we'll be using these two when we express the uncertainty. Now, if they ask you the question that represent the absolute uncertainty in the principal value. So for absolute uncertainty, what you have to do is value of I, the value of current was how much? 1.6 milliamperes. Uncertainty or absolute uncertainty in the current would be represented by delta I. Okay, so you see this triangle sign, this is called delta. It means we are talking about the uncertainty in the measuring quantity, in the quantity that is being measured. So in order to find the absolute uncertainty, what you have to do is take half of the precision. So what was the precision? Precision was 0.2. You divide it by 2, and there you go. You get the absolute uncertainty in the principal value. So what do you get here? You get 0.1 milliamperes. So that's it. You get 0.1 milliamperes as the absolute uncertainty in the principal value. Now, how do you write your final answer? Well, you write the final reading as I. The final reading equals to 1.6 plus minus, because it can be 0.1 places above the actual value, or it can be 0.1 places below the actual value, plus minus 0.1 milliamperes. Okay, so this is how you write the final reading. So they can ask you this question, they can give you all they can do is they can give you this table, they can give you this data, and they can ask you to write the principal value along with the absolute uncertainty. The principal value you read from the scale 1.6. Absolute uncertainty was founded once you found the precision. You divided the precision by 2, you get the absolute uncertainty, and then you write it as principal value plus minus the uncertainty. Alright, the next thing is fractional uncertainty. So fractional uncertainty simply means you'll be writing the uncertainty in the form of a fraction. So it'll be the uncertainty divided by, that you would have guessed by now, divided by the principal value. So it tells you how much uncertainty is there with respect to the principal value, divided by principal value. So what was the uncertainty? You take half of the least count, you take half of the precision, it was 0.1 like we did already, divided by the principal value. Principal value was 1.6. Then you hit it on the calculator. You can simplify the fraction, it'll be 1/16. You can get rid of the decimals, and you write the final answer as, so you write the final reading as, final reading equals to principal value, I equals to principal value 1.6 plus minus this fraction, the fractional uncertainty, 1/16 followed by the unit. Okay, so this is the second way they can ask you to write the uncertainty in the principal value. We have the third case and the most important one, that is the percentage uncertainty. So it is just a concept of mathematics. You simply find the fractional uncertainty and you multiply it by 100. What you get is the percentage uncertainty. Okay, by the way, absolute uncertainty in current would be represented as delta I. Fractional uncertainty would be represented as delta I divided by I, because I is representing the principal value, and the percentage uncertainty is represented as delta I followed by the percentage sign. Okay, these are three different notations for all three of them. In order to find the percentage uncertainty, you simply do the same thing. Uncertainty divided by principal value multiply by 100. What was the uncertainty? 0.1. How did we know? We read the least count, we read the precision, it was 0.2, then we divided by 2, we get 0.5. Divided by the principal, 1.6, multiply by 100. And then the next step, hit it on the calculator, you get the value of delta I percentage uncertainty in current. It'll be 6.25%. Okay, just do it on the calculator. How do you write the final answer? The final answer would be written as I equals principal value plus minus the percentage uncertainty. Principal value plus minus the percentage uncertainty followed by the unit. Like I said, there are certain rules for writing these writing the uncertainty with the principal value. I have not explained the rules right now, but what I can tell you is this would be written as 1.6 plus minus 6.3, so we have equal number of decimal places, percent of current. So this one is the right answer, but the representation is wrong. Okay, and this one is the right answer as well as the representation is also right. But since I have not explained the rules, there are some other rules also. I'll explain those rules in detail after we complete some other cases.